One-off LLM tests do not scale. Pytest.mark.parametrize turns every prompt case into a repeatable regression check. You'll understand the pattern behind a pipeline that assembles a parameter grid of prompts and checks regression runs. I'm Professor Pi, teaching AI engineering and LLM systems with simple Python. Teams run ad hoc prompts and trust eyeballs. That works for a few checks, but it breaks when models change, teams grow, or a release slips through. Pytest.parametrization gives you structure, a small matrix that runs automatically in CI. The payoff is catching regressions early while keeping false alarms manageable. At its core, this is a testing pattern, not a model. We turn prompts, models, expected outputs, and a few lightweight metrics into a table. Pytest walks that table and asserts behavior stays inside your bounds. That makes it easy to add prompts, flag flaky rows, and focus engineering effort where it matters. Conceptually, you want repeatable guardrails. Picture a single prompt that must always refuse a dangerous request. Now, multiply that by 10 prompts and 3 models. Parametrize fans out the combinations, so one test body covers every row. The strengths are low friction and clear ownership. The weaknesses are noisy snapshots and the need for assertions that tolerate safe variation. Project Preview. We will build a tiny Pytest harness that starts with a single locked prompt, then expands to multiple models, then to keyword coverage, then to handling an acknowledged flaky case, and finally to indirect fixtures that scale scenarios without rewriting tests. This shows how to evolve from a manual check to a maintainable regression suite. Quick note, this code is designed to teach the core idea clearly. Library versions and local setups can vary, so check the official docs if your setup behaves differently. We start by showing the minimal test that locks one prompt and one expected output. This snippet creates a minimal Pytest regression test that locks one LLM prompt to a known response. The core worry here is whether a tiny baseline can still flag regressions once you stop eyeballing outputs. We load 2 tuples into cases, build bank for instant lookup, and wrap run prompt so pytest.mark.parametrize cycles through each tuple. That keeps the assertion tight and lets you add prompts without rewriting the test body. The print shows cases prepared equals 2, confirming 2 guardrail prompts are currently enforced. Now we expand the harness so the same expected answers are checked across multiple models. This example fans the grid out, so Pytest checks every model against the same expected answers without changing the assertion. The risk is obvious. Adding a model doubles the rows unless you automate the combinations. Baseline stores the canonical math and tone strings. Responses holds per model maps, and run prompt simply indexes the right value. Stacked pytest.mark.parametrize decorators first iterate across prompts, then across responses, letting one assertion compare every row in the matrix. The print reports matrix cases is 4, making it clear 2 prompts times 2 models are under watch. Next, we stop relying on full string equality and move to checking preserved safety keywords. This code scores safety keywords, so Pytest asserts each model keeps critical phrases even when wording shifts. The practical problem is regressions where tone softens, but key refusals disappear, so we track literal hits instead of full string equality. The cases list captures model name, captured text, the tuple of keywords, and the allowed limit, so pytest.mark.parametrize can fan through safety checks with IDs for quick lookup. Inside test keyword coverage, we sum hits, normalize by keyword count, and assert the result stays above limit. giving a repeatable metric to compare across revisions. The print reveals coverage thresholds equals 2, signaling 2 independent guardrail probes are configured. Then, we show how to mark one known noisy case as expected to fail, so the rest of the suite stays useful. This snippet quarantines a known regression by marking the noisy model case xfail, while the passing case keeps the baseline green. The practical decision here is how to document flaky numeric formatting without deleting coverage or letting teams forget the bug. Outputs stores the 2 responses. We reuse pytest.param to declare each expectation, and xfail words captures pytest.mark.xfail with an explicit reason. When pytest hits test numeric format, it still executes both branches, but only the GPT Pro row is tolerated to fail. The print surfaces xfail known equals 1, reminding you one scenario remains on the watch list until the formatting fix ships. Finally, we show an indirect fixture pattern so scenario configs scale cleanly across experiments. This code turns scenario dictionaries into indirect pytest fixtures, so summary prompts stay aligned across evolving configurations. The decision point is how to feed model, prompt, and expected prefix into one test once experiments start multiplying files and knobs. Cases builds the configs with a comprehension, so adding new models is just adding names, while outputs maps each model to the canned summary text. The scenario fixture fetches request.param, looks up the text, and returns a tuple consumed by pytest.mark.parametrize with indirect true. The print echoes scenarios configured equals 2, confirming 2 scenario definitions will be exercised in the harness run. In a real product, this pattern maps to a folder of scenario files plus a small cache of golden outputs. Each commit runs the matrix in CI and flags rows that cross thresholds. Engineers triage failing rows and either update a golden answer, relax a metric, or file a bug. That preserves history and reduces noisy pager calls. Recap. You now have a compact pytest pattern that fans prompts and models into a test matrix. Use it when you want automated regression checks for prompt behavior and model upgrades. Prefer targeted assertions or keyword coverage over raw snapshot equality, because snapshots tend to be brittle. Next step. Scale this harness by adding a timing check and an ANN index for larger corpora to measure latency and recall under load. If short, practical AI engineering helps, subscribe and watch the AI engineering videos.